the romance of steam. Once virtually extinct, today steam locomotives are experiencing a welcome return. And those of us who work these magical beasts understand their beauty and power. They draw us into their spell. But unless we give them our respect as well as our admiration, they can turn deadly. On June 17, 1831, the first fatal accident in American railroading was a boiler explosion on the Best Friend of Charleston, the nation's first passenger locomotive. The fireman was killed. 164 years later, almost to the day, on June 16, 1995, railroading experienced one of its most recent boiler explosions. The engine crew was seriously injured. The railroad's operations faced extensive disruptions, and some 2 years later, the locomotive remained out of service. The National Transportation Safety Board investigation determined that the crown sheet failed from overheating because the train crew had allowed the water in the locomotive boiler to drop to a level that was insufficient to cover the crown sheet. The investigation also determined that the boiler and its associated equipment had not been maintained well enough to ensure safe operation. The NTSB concluded that the railroad's management failed to properly train the crew. The result: needless damage, tragic injury, lost revenues, and increased expense for the railroad. We'll examine this accident in more detail. But the first of several factors related to the accident was noted earlier in the day: a leaky check valve flange. In response, the firemen shut off the feed water heater system, one of the several factors leading up to this avoidable accident. The Federal Railroad Administration regulates minimum standards for the inspection and maintenance of steam locomotives to ensure that railroad travel is safe for both passengers and crew. These regulations, found at 49 CFR Part 230, address the inspection and maintenance of the steam locomotive, its tender, and any parts and appurtenances thereto. A basic inspection of the locomotive should be performed each day. In many operations, the engineer and firemen will perform this inspection. Some railroads have the mechanical department do the inspection. In either case, the engineer is ultimately responsible for the safe operation of the engine. This presentation identifies some key areas to be covered in a daily inspection, as well as some essential safety issues for the engine crew while the locomotive is under steam. While locomotives are not all the same, the procedures outlined here should form the core of your daily inspection routine. Keep in mind you are looking for obvious problems: leaks or loose, misaligned, or dragging parts, for example. Remember, every engine undergoes a cycle of comprehensive inspections. During these inspections, with the engine out of service, the boiler and other essential items are thoroughly examined and cleaned. Whenever an engine fails to meet the specifications listed in the regulations, it is said to be in non-compliance. When a non-compliant condition is found, whether in these extended inspections or the daily inspection, the engine must be removed from service until the condition is corrected. The daily inspection is a supplement to the engine's more comprehensive inspections. It is meant to ensure the locomotive and its various components are safe and suitable for the current day's operation. It is good practice to develop a formal checklist or daily inspection form to assist the inspectors. Any problems should be noted on the form. Most daily inspections begin in the cab before boiler pressure has been built up. The engineer checks to see that the forms required by FRA regulations are properly posted in the cab. First, check the water glass to be sure there is sufficient water in the boiler. If there is steam, you should perform the water glass test. This is extremely important and is also known as blowing down the water glass. This daily check is required by federal regulation. In addition, it is recommended that you blow down the glass several times during the operating day. Consider the accident we described earlier. Had the engine crew adequately understood the functioning of the water glass and responded appropriately to what they were seeing, the accident could have been avoided. First, the NTSB investigators found the water glass light was inoperative, in violation of the regulations. Second, the crew reported they thought the glass was operating the way it should and was indicating an acceptable water level, even though the water only varied in level by about a half an inch. To a properly trained crew, this would indicate a serious obstruction in the water glass line. And a knowledgeable crew would also recognize that this could hide a potentially serious situation. When the investigators removed the glass and examined the valves and lines connecting to the glass, their suspicions were confirmed. The water glass spindles were 75 to 85% plugged by hard scale. A properly operating water glass, either tube type or reflex type, is crucial to the safety of engine operation. Its design and operation is actually quite simple. Because water always seeks its own level, the amount of water in the glass indicates the amount of water in the boiler. Note that the top part of the glass is open to the gases, air or steam, present in the boiler. Water must cover the top of the boiler crown sheet at all times, so it will not overheat. A properly operating water glass will confirm this. Regulations further require that the water glass assembly and all gauge cocks be thoroughly cleaned. Further, and of immediate importance for the engine crew, all water glasses must be blown down before each trip or day's work. This procedure is crucial and can identify potential problems. Begin by closing the lower water glass valve. Now, open the drain cock. The glass should immediately empty, and steam should blow through the glass. Next, close the upper water glass valve. At this point, nothing should be draining from the water glass. If water or steam continues to drain, it indicates that one or both valves leak, which may make it impossible to prevent steam and water from entering the cab in the event of a water glass failure. Now, open the lower water glass valve. Water should immediately flow out of the drain pipe, and if the glass is directly connected to the boiler, water may even quickly fill the glass. Also, if the drain valve is wide open, bubbles may appear in the water. If, however, the glass is on a water column, water will probably not appear in the glass. Now, open the top valve. The glass should show no water level, unless the boiler is very full. Close the drain valve, and the water level should return to normal quickly. If the water glass you are inspecting does not respond as described here, if water continues to drain when it shouldn't, or it responds sluggishly, a serious condition exists. The water glass assembly should be removed, thoroughly inspected, and repaired. Steam locomotives may also have 3 gauge cocks for checking the water level as well. If so equipped, this system must be properly inspected and maintained as well. Open the top cock. If water doesn't flow, open the middle cock. Then finally, the lower cock. If the gauge cocks are open, water should be flowing from at least the bottom gauge cock. If no water is flowing, or steam is appearing instead, a serious low water situation exists. A special note here. Investigations of boiler operation in the 1920s confirmed a long-held suspicion. There is a water surge phenomenon associated with a locomotive boiler during operation. This can cause the gauge cocks to show the water level to be higher than it actually is. This false head effect is caused by heated and circulating water, which swells near the junction of the crown sheet and the door sheet, where the gauge cocks are generally located. Thus, this caution. Even though water may flow from one of the gauge cocks while the boiler is under pressure, it is possible that a low water condition could exist. Therefore, the gauge cocks are meant to be, at best, only a backup to the water glass. Now, continue the daily inspection by checking the fire door for proper fit and for proper manual operation. Later, when a coal-fired locomotive is under steam, you should check to be sure its door will open by air. With the door open, check the arch tubes for leaks. Also, as carefully as possible, check the crown, side, flue, and throat sheets for leaks. Check the brick arch or fire pan refractory for damage. In general, evidence of leaks will appear either as actual drips or thin white trails. This completes the firebox interior inspection. With the door closed, your inspection continues inside the cab. Inspect valves as appropriate for leaks and ease of operation. Additional operational checks in the cab area require the locomotive to be under steam. So, while the fireman builds the fire and the pressure is raised, the engineer can inspect the rest of the engine and tender. First, confirm that the wheels are properly chocked and the locomotive and tender are protected from movement. As you move around the engine, note any problems with the safety appliances, steps, handrails, etc. Remember, throughout a daily inspection, you are looking for obvious defects, especially leaks. Practically speaking, as you move around the engine, you will be surveying several things at once. Again, since leaks can indicate critical conditions and lead to dire consequences, you should take care to examine every washout plug for leaks. In addition, pay close attention to stay bolts with telltale holes. Any unusual appearance is cause for concern. Leakage from the telltale hole indicates a cracked or broken stay bolt. Also, be aware that the source of leaks under the lagging or jacket may not be immediately apparent, but may indicate a serious condition. On both sides of the engine, check the mechanical components of the engine. You may want to carry a hammer with you to check some of the wedges and nuts. A tap with a hammer can indicate looseness, a crack, or other problem, which is identifiable by sound or movement. Check all knuckle pins, crank pins, and wrist pins and nuts. Check rods for lateral movement. Look for points where there may be excessive play. Confirm that knuckle pins and rods are clear of all driving wheels. Check all rods for cracks and rod brasses and bushings for excessive wear. Inspect the crosshead guide bars for cracks, fit, and tightness. And check the piston key to be sure it is tight and properly secured. Examine the crosshead for play, side to side and up and down. Confirm that the frame keys are in place and properly fitted. As you perform your inspection, notice any cracks or unusual or excessive wear on the wheels and their flanges. Check sandpipes for proper alignment to the track. Sandpipes should be at least 2.5 inches, but not more than 4 inches above the track. Daily testing of the sander is also required by federal regulation. Each journal box must also be inspected for proper appearance and oil levels. Examine the locomotive's springs and rigging for wear or damage, such as broken leaves. You should include all driving springs, noting that they are horizontal on level track and free and clear of the driving wheels and frame. All equalizers and spring saddles. Spring hangers, pins, and bushings, making sure all are properly secured. Some of these items must be viewed from under the engine. However, even without a pit, it is essential to inspect the underside of the locomotive for these and other items. Examine the truck springs. If your engine has a lateral motion device, inspect it for proper appearance and lubrication. Check to see that the pedestal binders and bolts are tight. Confirm the presence and proper appearance of the cellar bolts and keys. Check the crown brasses, driving boxes, and driving box shoes and wedges. Shoes must be tight, and wedges must be properly adjusted. Examine the brake rigging and safety hangers, confirming that nothing is loose, and that when the brakes are set, all beams and rods are clear of other hardware. If there are journals accessible from under the engine, confirm that they contain sufficient oil or grease. When you have completed the underside inspection, you should turn your attention to the tender. Look for the same types of issues on the tender as on the locomotive, that the equipment is in a safe and suitable condition for operation. Check wheels for unusual wear, the braking system, including proper alignment and excessive wear, side bearing clearance, the rear coupler, including the key and yoke rivets, the rear knuckle and pin, to see if the pin is bent or broken, and the carrier iron, to be sure it is securely attached. There are certain items that can only be checked when the boiler is under pressure. These include injectors and/or the feed water heater system, safety valves, air brakes, reverser, whistle or horn, and lights. Daily testing of the injectors is required by federal regulation. There are two types of injectors, lifting and non-lifting. The lifting injector uses steam to create a vacuum, which lifts the water into the injector before the injector can become fully operational. Begin this priming operation by pulling slightly back on the injector handle. The presence of water in the injector will cause the sound to change. Now the injector valve can be fully opened. The changing sound of the operating injector is the best indicator that it is functioning properly. All controls should operate freely, and the injectors should be free of leaks. The second type of injector is the non-lifting type. Here, because of its design and location relative to the water source, water should always be present in the injector. Therefore, the sound should immediately change when the injector handle is opened. Note that federal regulations require that engines have two systems for supplying water to the boiler, either two injectors or one injector and a water feed heater system. All water supply systems must be tested each day. There are three major types of feed water heater systems. Take care to perform the correct testing procedure for the system on your engine. Feed water heater systems are efficient only when the engine is moving. Injectors deliver water efficiently whether the engine is standing or moving. Now, continuing with the inspection. The safety valve must also be tested. Bring the boiler pressure to the level required to lift the safety valve with the lowest pressure setting. Confirm that the valve lifts and seats properly. A standing brake test is also a daily requirement of the federal regulations. Once the air compressor has charged the system to the proper pressure, test the brakes. Observe the effect of moving the valves on the appropriate pressure gauges, the main reservoir pressure gauge and the gauge for the brake cylinder and brake pipe. Once the brake is set, inspect the brake shoes and pistons. The brake shoes must be applied to the wheels evenly. Make sure the brake cylinder piston travel is correct. Also, test both the locomotive and tender headlights. Set the reverse lever to be sure it operates properly and that it latches firmly in the quadrant. One additional note, you'll also want to check the throttle in a similar manner once the engine is underway. Finally, check all signaling devices, whistle or horn, and bell. The fireman's key responsibilities are maintaining proper water level in the boiler, the fire, and the steam pressure. In addition, the fireman has other responsibilities as well, which impact on the safe, uninterrupted operation of the engine. For example, the fireman should open the filler hole to confirm the water level. Check for a full load of coal. Be sure that the drain pipes are clear and drain properly. And confirm there is a spare shovel on board. Additional responsibilities include checking all required flags and markers, making sure the firebox grates are level and secured, the ash pan is closed, and the squirt hose, if used, is in working order and properly stowed. Also, the fireman should confirm that the sand dome is filled. This completes our overview of daily inspection procedures for steam-powered locomotives. As noted at the beginning of this presentation, your own inspection procedures may vary somewhat depending on the specific engine. However, each of these systems on your own locomotives must be included in your daily inspection routine. Depending on your particular engine, there may be additional items you want to check as well. Remember that several of the procedures described here are required daily by federal regulation. Had each member of the crew on engine 1278 been aware of these regulations and performed the inspection outlined here, the accident of June 16, 1995 could have been avoided. There were 12 conclusions, 12 contributing factors, which the NTSB listed in determining the cause of this accident. Several have been discussed in this presentation. All of them were avoidable. With proper training, the risk of accident is significantly reduced. And safety is, of course, your primary concern on every trip, not just at the beginning of the day. Experienced engine crews are continuously checking the operation of their engine and noting potential problems. You should keep a list of problems that develop while underway and report these at the end of the trip. While the engineer is ultimately responsible for the operation of the engine, The fireman should know how to stop the train during an emergency. Communication between the engineer and fireman is essential. Any problems, particularly with the boiler or water supply systems, should be reported immediately. As during the daily inspection, while underway, sound plays a critical role in helping to identify potential problems. Listen for pounding, clicks, and knocks, or any unusual change in the sound of the engine. For example, priming and foaming are similar conditions which can affect engine performance and safety. Priming is when too much water is in the boiler, and foaming results from water which contains impurities, such as oil, organic matter, or a buildup of solids in the water. In advanced stages, foaming can be identified by bubbles appearing in the water glass. However, these conditions are also identifiable much earlier by sound. The normal sounds of the whistle and even the exhaust from the cylinders will change, becoming muffled or unusual. Engine performance degrades noticeably, and in extreme situations, foam may even be ejected through the stack. It is a serious condition, which requires an immediate response. Experienced engine crews are constantly monitoring the locomotive for this and other problems, thus minimizing the possibility of extreme situations. A steam locomotive transports us to another time. For many of us, that's reason enough to work on these magnificent machines. They can fulfill all our expectations, but only if we accept the responsibility to operate them with care and attention. Being responsible means being knowledgeable, and that means knowing how the engine functions, what to inspect at the beginning of the day, what to monitor during every trip, and how to take effective corrective action. The Federal Railroad Administration has provided rules and regulations which specify minimum safety standards. Failure to observe these rules invites fines, equipment damage, extraordinary expenses, and tragically, injury or even death. On the other hand, observing the FRA's regulations will help ensure you'll have the safest trip possible for your passengers, your train, and for you. Today, there are only a handful of these engines in service. As a crew assigned to one of them, you are part of a select group of people. What you are doing helps preserve our past. With proper training and a solid understanding of your job, you provide enjoyment for millions of people and ensure the legacy of steam power will live on.